Okay. Hello, everyone. I'm Dr. Haris Khan, and together with me is today's Dr. Hasan Saeed. Dr. Hasan Saeed is a registrar in University of Lahore. Do you want to say something about yourself, Hasan? Do you want to say something about you?
No, sir. Continue
Okay.
करना है.
Uh, we made this, video to uh, tell a simplified solution for moment to force ratio. So the moment to force ratio uh, is written MC or MF or versus MC/F. So these are two different terms, and many a times students get confused that which one is the right one. So both are similar. So in terms of unit, if we see MC is calculated by force multiplied by distance, and same is the case with MF. MC is the moment of couple, and MF is the moment of force. The moment of force is produced when a force is applied, while the moment of couple is produced by our mechanics. So if we see MC or MF, MC or MF do not have any unit. So because it's a ratio, so it do not have any unit. MC or MF, no unit. While MC, that is a moment of couple by force ratio, has a unit that is equal to millimeter. Which article, Hassan, it was there that it has a unit? Because in some old article it was mentioned.
It was mentioned in a basic article by the Isaacson and the Burst one. It's almost in the 1970s.
Okay. So in 1970s, even in, I remember that in a letter to the editor in AGO, someone mentioned that MC over F, or the moment of couple to force ratio, has a unit, because these are not similar terms, so we cannot make a ratio of it. And the unit would be most probably millimeter, because the force will dissipate force, but the distance will remain there in the moment of couple, so it would have a unit. But the terms used in contemporary orthodontics by William Profit, that is moment of couple divided by moment of force, that would have no unit. Uh, that would have no units. And the moment of the couple, or the moment of the force, it has a unit, and that is MC or MF. Its unit is gram, that is for force, and millimeter. Some articles write Newton, millinewton by millimeter, but for the ease, we'll use unit of gram millimeter here. So the first scenario is uncontrolled tipping, and in moment to force ratios, there are 2 points, that is the center of resistance and the center of rotation. The center of resistance is a fixed point, while the center of rotation change. And for the center of resistance, there are variable definitions, like what the center of resistance can be 40% from the root apex, or that is actually from the crestal bone, and we made it from the crestal bone. How much, Asan, it is there from the crestal bone?
Usually 1/3 from the gastric bone.
1/3 from the crestal bone. And in which book reference is there? Because in old contemporary orthodontics by Profit, that was from the root apex.
This is referenced by the Nanda.
Okay, that is the reference by Nanda, that either you use from the crestal bone, or by Profit in contemporary orthodontics, it was from the root apex. So the first scenario, in the moment of couple to the moment of force ratio. First, we will explain the moment of couple to the moment of force ratio. MC, and that for uncontrolled tipping. MC/MF is equal to 0, right? So why it equal to 0? So to explain this example, first we will see the moment of the force. So moment of the force, usually when these people, the researchers, done their study, they noticed mostly the root apex is 8 to 10 millimeter. The center of resistance from the point of application is 8 to 10 millimeter. the point where the bracket is placed, or where the wire touches, if it's a removable appliance, where the wire touches the tooth, to the center of resistance is 8 millimeter or 10 millimeter. So for the ease of explanation, we will keep 10 millimeter here. So if we apply a force, the force will, if it's a canine, the force will retract the canine backward. So there would be two things happening. One is the force that is retracting the canine backward, um, uh, that is creating a movement. So if we have to calculate the moment of force that is actually rotating the canine, and I will draw a diagram that what is the moment of force here. Um, yes, yes. I think there's some issue. Do you see the diagram?
No.
Yes. Eraser. I think the format was done. I will again use eraser. So this is a canine. So the moment of force, if the force is coming from the backward direction, so the moment of force will tip the canine backward.
Yes. Please draw the force arrow as well.
Yes, the canine is going that way. So moment of force is calculated by, that is a force, and the force which we have applied, we can easily measure that force by, different gauges, multiply by d. We suppose that we do not have any hook on the canine to make it simple, and the distance is 10 millimeter. So is equal to, force is whatever force. So we say, let's suppose we applied 100 gram force to retract the canine backward, and the distance is 10 mm. The 10 mm distance is from the point of force application. Um, let's say this is a point of force application, and that is the center of resistance. So this distance is d, and the force is a backward force we have applied here. So the force here would be, the moment of force here would be 1000 gram millimeter. Am I right, Hassan?
Right, right, right.
Okay. The second component here would be moment of couple. So as it's a removable appliance, if it's a removable appliance, or we have used a very light wire that is very flexible, then in that case, there is no couple acting along. Because if it's a removable appliance, we are creating no couple. Both force, we are not creating any force here. There's no distance. Both are equal to 0. So when we say that moment of couple slash moment of force, that would be 0 divided by 1000. And the result would be 0, because there's no force and there's no distance as such involved. So there's uncontrolled tipping. The crown is moving backward. The canine crown is moving backward, and there's no force acting in the opposite direction to rotate the canine. So the canine is just tipping uncontrolled. And one thing I want to explain, when we are giving the example of canine, we are calculating moment to force ratio in the second order bands, because we can calculate moment to force ratio in 3 dimensions. That is first order, the in and out bands, we can calculate the moment of force there. When we are calculating the moments of force ratio for a canine, that is the retraction of the canine, we are calculating the moment to force ratio in the second order fraction. And when we are calculating the moment to force ratio for the incisor torque or the incisor retraction, we are calculating the moment of force ratio in the third order direction. So moment to force ratio for retraction of the canine is different than moment to force ratio for the canines. For the canines are different than the incisors, because
Right.
canine is second order, and and the inside the retraction is third order. So I will erase this one. So moment to force ratio for if the moment of couple is not present, then the even the moment of force is present, the result would be 0. So that's why when we say moment of the couple to moment of the force, it means equal to 0. It means that there's uncontrolled tipping. Now there's another scenario. Some other books like Nanda, I think Nanda also say moment of couple to moment of force. That is
Yes.
moment of couple to force ratio. That actually has a unit, but many a times researchers do not use a unit for this. And they say that in uncontrolled tipping, it should be less than 1. Uh, I have a doubt here that because in like with removable appliance, there is no couple being produced. So less than 1 is equal to 0. The same example is there because moment of the couple, as I told you, there is no moment of couple, it's 0. And whatever the force would be, like what as we gave the example that it would be 100 gram. So it would be straight away 0. But as they have said less than 1, I think I have some doubt about less than 1 because even if 0.1 or 0.2, there's some control in the tipping process. So I have some doubt that this sentence is not right, that is less than 1. What do you think, Hassan?
Yeah, exactly. Right.
Yes, even it's a flexible wire, if it's produced some tipping, because if we add something in the movement of the couple, it's not a removable appliance then.
Exactly.
In removable appliances, no movement of the couple. Like what? But if I pass a wire through the bracket, and if some counter couple is produced, that is in the opposite direction to the moment of force, then there's some control in the tipping. So I'm doubtful that in moment of couple to force ratio less than 1, because I think it should be 0. It should be 0 rather than 1, because there is no moment of the couple present. And frankly, whenever there is a couple present, it should be more than 0. And that's, there's some control in the tipping. So we'll keep the example of the retraction of the canine. And I'll draw the canine once again. So this is a canine. This is a canine bracket. The force is going this way. This is a center of resistance. And we're retracting the canine. And this is for the force. And ideally, this is for movement of force.
Moment of force, MF.
Yes. And ideally, this should be the movement of the couple. It should be this way. So the second scenario is moment of couple divided by moment of force. That's equal to, that is less than 1, right? Hassan, that is less than 1.
More than 0 and less than 1.
Yes.
Yeah.
More than 0 and less than 1. So how this values actually come? So so first of all, I will see the moment of force. That is, that is in the clockwise direction on the canine. And let's say that is the right side canine. So first moment of force. What will be the force here? 100 gram, as we have given the example.
It's the same example, 100 gram
Same
force and
example,
1000 gram
10
moment.
millimeter,
Yeah.
and the distance would be
Distance and 1000 gram moment.
Distance would be 10 millimeter. So the moment that is produced is 1000
1000
gram
millimeter.
millimeter. And about the moment of the because this happens, we can now produce the movement of the couple to control the tipping. For movement of the couple, either we should add another wire in the removable appliance. Might be it's from the, if one wire was from the mesial aspect, the other wire would be on the distal aspect. But I will stick to the example of the fixed braces, that we added a wire in the fixed bracket. So when we add a wire, if it's a segmental mechanics or it's a continuous mechanics, and when the wire is there, if it's segmental mechanics and we are using loops, if a gable band is there, then we are producing a movement of the couple. And for the movement of the couple, again there are two aspects: the force. Uh, the force is produced by, how we produce the force, Hassan? Do you have any idea? In movement of the couple.
The force is basically the bending of the angle of the wire, which is the basically the torsion of
Yes,
which
that is
contact
basically the
angle from the
contact
mesial
angle.
and the distal aspect of the
Yes,
bracket.
that is more like contact angle.
Contact angle.
Yes, and also it depends on other properties of the wire, like the interbracket distance, right? I
Yes.
think less the
Also the
interbracket,
dimension of the wire
yes,
and everything.
the dimension of the wire, the interbracket distance, less the
Material.
interbracket distance, I think more would be the second order band would be expressed. Is it true, right?
Right.
So less the interbracket distance, the material of the wire, the size of the wire, the force is a sort of indiscriminate here. We cannot actually measure the actual amount of force, but what we can measure here is the distance. The distance here is, that is the width of the bracket.
How it is weighted with the bracket?
It's a mesodistal width of the bracket, right?
Right.
It's a mesodistal width of the bracket, and that can be, let's suppose, 4 millimeter.
Yeah.
And
Ideally speaking,
yes,
the width of the bracket is basically the distance between the two contact angles.
yes,
How much the distance is here the overall the bracket width is 4 millimeter. The actual distance is 4 millimeter. That's the we're considering 4 millimeters.
yes. So the width of the bracket is 4. So if we have 4 millimeter and we want bodily movement, then we need to 50 gram of force for effective bodily movement, for effective movement of the couple. So that would be 250 multiplied by 4, because the bracket of the width is constant. So we know that we need less movement, that is to 50 gram, to create 1000 gram
Yeah.
millimeter of force. I hope I'm right.
Yeah.
So in this case, but here we are not going for bodily movement. Here we are giving the example of a movement of couple more than 0 but less than 1. So if we apply less force, because a bracket width is fixed, but if we suppose apply less force, like what, let's say 100, the end result would be 400.
400.
Yes. So make it into the equation, MC divided by MF, 400 divided by 1000 is equal to 0.4.
0.4.
Yes, 0.4 gram slash millimeter. I hope I'm right.
No,
So
there will be no unit of the word.
yeah, sorry, there's no unit when the moment of force ratio is there. So it's a 0.4 moment of couple to moment of force ratio. So it means that it's greater than 0, but it's less than 1. And this means there's uncontrolled tipping, because for bodily movement, we need 250 here instead of 100.
Control tipping. Control
Yes.
tipping. So that.
Because for bodily movement, we need 250 gram of force, but we applied 100 gram of force. So there was some control to the retraction of the canine, but it was not full control. But now the second scenario is that some people say that for the same scenario, that is moment to force ratio, that is moment of couple to force, that is equal to, Hassan, that is
The
equal
8 to 10, add 8 to 10. It all depends upon the distance between the
yes, yes.
actually the
We
center
suppose
distance
that
to the
it's 10
bracket.
millimeter. We suppose it's 10 millimeter. Then what is the moment of couple to force ratio for uncontrolled tipping?
8 to 10.
Okay, I say 10 because we are considering 10 millimeter, right?
Yeah, it can.
So here the moment of the force is definite, that is 100 gram, right?
No,
Force is
if
100
the
gram.
distance is basically for a controlled tipping, if the distance we consider is a center is 10, then it should be less than that. From like
Yes,
9.5,
yes,
even 9.9 till 9,
yes.
from like
Sorry,
more than one,
it's
all the
less
distance.
than 10.
We are less than 10.
Yes,
10 is for the bodily movement.
yes. So moment of couple to force less than 10. As we have decided that we will keep the force level at 100.
Yeah.
So now it's the moment of couple, right? In moment of couple, as I said ago previously, that is a force is indiscriminate, but the distance is definite. So F multiplied by D. So if we keep the force, like what in the previous example, we kept the force at 100.
Yes.
Uh, so if we keep the force small, because we have fixed distance that is 4, and if we keep the force like what 100 uh, multiply by 4, we are getting 400 gram of force. 400 gram, 400 millimeter here. Exactly, the unit is this way. Sorry, 400 gram millimeter because it's movement of a couple. So this is a scenario. So here
So
we
the
have force of 100 gram, and so the moment of couple is 100, and moment of force is the force is 100 gram, and the moment of couple is 400 gram. So we will divide it 400 slash 100. It will become 4, right? So
right.
it become 4. So if it's become 4, it means there is uncontrolled tipping. For controlled tipping, there should have been 1000, right? Because in that case, it should have been,
If it's 1000, then it will be bodily movement. The
yes,
answer will be 10.
yes. If it's
For
1000, then
controlled
it would
tipping,
be, the answer would be 10 and it would be body movement, but the answer is 4. So it is uncontrolled tipping here.
controlled tipping here.
Yes, there is controlled tipping.
Controlled.
So there is controlled tipping here. So I will go to erase it and we will move to the next scenario. So we move to the next scenario, and that is bodily movement. That is MC slash MF, and what is equal to 1.
One.
Okay. We go for moment of force. That is force multiplied by distance. And what is the force?
It's the same. It's the same. Say MF is 1000. I think
100. The force is 100 multiplied by
100 force and the distance is 10
10. So it's 100 gram, 1000 gram dash
millimeter.
millimeter. Now we calculate the moment of the couple. The moment of the couple we have to calculate. We have to manage the moment of the couple.
Yes.
So in that scenario, uh, if I have to go for bodily movement, I have one dimension, that is the width of the bracket, and we have supposed it 4 millimeter. 4, because it's F multiplied, we say it's D multiplied by F, it's the same. So one thing is fixed, that is 4. So we have to make it 1000. So if we have to make it 1000, then we need a force of 250 to make it 1000 gram millimeter. If we apply less force, it will be uncontrolled tipping, and if we apply more force, it might go to the torquing moments. So this why if we divide this one, it has no unit and it will eventually become 1. So the second scenario is which other books explain, that is the moment of the couple to moment of force.
Yeah,
Uh,
only force.
huh? Sorry,
Only force.
only force. That is by Nanda. That is 8 to 10, right? 10, because we're considering,
10.
yes, equal to 10. So that's equal to 10. So if we have to calculate this one, it's mean that moment of couple, we have to calculate the force first. That is, as we have decided already, it is 100 gram. While for the force, so if it's 100 gram and it's 10 millimeters, so it's the same scenario that it should be, the moment of the couple should be 100 gram, uh, moment of couple should be 100 gram, 1000 gram,
1000.
gram millimeter. So how we calculate it? It would be the similar formula, MC is equal to D multiplied by F, where D is 4 millimeter. If I want to explain one thing, if we are calculating the force in the first order, in the second order direction, then in that case, uh, it is the it is the uh, width of the bracket that matters. So here we have 4 millimeter constraint. So if we have to if we keep it, if we make the force at 250, it will become 250 gram. So yes, so it will become 1000
1000.
gram millimeter. So it would be 1000, yes, 1000 divided by 10.
100.
100, yes,
100.
force is 100.
4.
So the result would be 10.
10.
So it means it would be a bodily movement because we have supposed that the center of resistance is there. Just give me a minute. Okay. So in this way, these ratios will come, uh, this ratio will come in the range of, that would be, because it's a moment of force, that should be 10 millimeter if we are going to place the unit here. So this is the Baldi moment. Now the last scenario is, what is the last scenario, Hassan? You have to tell me. Moment of couple,
MC. MC or MF
MC or MF,
should
yes,
be more than 1.
greater than 1, right?
Right.
Because previously it was equal to 1. It's greater than 1,
Yes.
right? And the other ratio is MC slash F is equal to 12 or something like that.
More than 10.
More than 10, yes, we write more than 10.
More than 10. 11, 12, anything it can be.
More than 10. So we will calculate the MC over first, the first equation, MC over MF. So the first we will calculate MF, that's equal to F multiplied by D. The force is, we already decided that we are applying 100 gram of force, and the D is fixed to, that is 10 millimeter, right? Right, Hassan?
G.
So it's the MC that matters here. So if we are like what using a heavy wire, or we are giving a second order bands in the wire, or the hooks present on the canine that has decreased the distance, um, and we are creating a greater twist in the wire by the, or the bracket width is greater, so we can change this for a greater root movement, or by gable bands increasing the angle of the gable bands, we can change the MC. So it's d multiplied by f. So as we said that we keep the D, that is a width of the bracket, mesodistal width of the bracket 4. Then keeping a force of greater than 250 gram per millimeter, like what we applied 400 gram of force, it will create 1600 gram millimeter. So it means that 1600 divided by 1000, that would be 16. That is greater than 10. Or if we say that the previous value is 300, it means 1200. So that is 1.2, sorry, not
1600 by 1000 is 1.6.
1.2. That was previously, it's either 1.6,
It's actually more than 1. It will be
1/6 or 1200 divided by 1000
1.2.
is 1.2. So it's greater than 1. It's greater than 1. So it is a root movement or the talking movement. Now we move to the second scenario. The second scenario is MC/F. Moment of, what is the moment of a couple? Sorry, first we will calculate the force here. That is greater than 10, right?
Greater than 10.
Yes, more than 10. So how we calculate it? If we apply a force that is a retraction of the canine, that is 100 gram, and now we need more distal root movement, then we have to create a greater movement of the couple. So for the movement of the couple, I will keep the D fixed. Either we can increase the mesodistal width of the bracket, but usually the bracket are supplied from the manufacturer. There's very little change we can make in the brackets. So we have to make changes in the force we generate. We can increase it by gable bands, as I already explained. So this force is changed. So let's say 4 multiplied by the same scenario. I will say 4 or 4 multiplied by 3. 4 multiplied by 400.
No.
Right?
Right.
So the result would be first 1600, right, divided by the force, that is 100. The result would be 16.
16.
Or the result would be 12. So that's why they say it's greater than 10. It's almost the same thing. And when we say 10, it's greater than 10, it's 12 or 16, it means that this distance has actually increased. We move closer to the roots, or we are applying force at the level of the roots. Previously, for bodily movements, we are applying force at the center of resistance. Now we are applying force for torquing. We are applying force at the level of the roots. For uncontrolled tipping, we are applying no force. We are applying force at this level. For controlled tipping, we are applying force in all this region, that is uncontrolled tipping area. So this is torque area, or the center of resistance move upward. We are applying force at this level, irrespective of the center of rotation. When we apply force on this area, the center of rotation is at the if we apply force at the level of the crown, the center of rotation is at the level of center of resistance. But if we apply force slightly above, the center of resistance move upward. Center of rotation moves upward, sorry. And if we apply force at this level, the center of rotation would be at somewhere at infinity, because we are applying the force at the center of resistance. But if we apply force at the root apex level, because if you see we are applying force at the level of 16 millimeter or 12 millimeter, then the center of rotation will come to the I think the root at the incisor edge.
Incisal edge.
So this is for the moment to force ratios for the canines. I think, Hassan, we can make a separate video. Let's see this video.
Exactly.
And we can make a separate video for the inside.
Video for the incisor retraction.
Okay, I'm going to stop this one.